Hi! If you throw a basketball, its trajectory is a parabola, that is, the graph of a second-degree polynomial. A lot of models in, for example, engineering or physics rely on polynomials, so equations involving polynomials also occur often. In this video, we look at equations of the form p1 of x is equal to p2 of x, where p1 and p2 are polynomials. For example, this equation. Graphically, this means that we try to find the x-coordinates of the intersection points of the two graphs. As a first step, we simplify the equation by bringing all the terms to the left. We see that the left-hand side here is again a polynomial. This is always the case. The equation p1 of x equals p2 of x reduces to an equation of the form p of x equals 0 for some polynomial p. That is, we try to find the zeros of p. We start with the simplest case. P is a polynomial of degree 1. Now we need to solve the equation ax plus b equals 0 for x. Well, you know what to do here. Bring b to the right-hand side and divide by a. Then the solution is x is equal to minus b over a. Next we look at equations of degree 2. First, you look whether you can factorize. For example, if we want to solve x squared minus 8x plus 12 equals 0, we factorize the polynomial as x minus 2 times x minus 6. You can check this by expanding. Now we have an equation of the form a times b is equal to 0, so that either x minus 2 is equal to 0 or x minus 6 equals 0. This gives x is equal to 2 or x is equal to 6. What if you don't see how to factorize? Well, in this case you can either use the quadratic formula or you can complete the square. Let's first use the quadratic formula. D, which is b squared minus 4 times ac, is called the discriminant. We can see from the value of d how many solutions our second degree equation has. If d is negative, the equation has no solutions. Graphically, this means that the graph of the second degree polynomial, a parabola, does not intersect the horizontal axis. If d equals 0, there's exactly one solution, and if d is positive, there are two different solutions. For example, we want to solve this equation, so a is equal to 3, b is minus 8, and c is equal to 4. We plug this into the formula, then we see that the discriminant is equal to 16, which is positive, so there are two different solutions, namely 2 and 2 over 3. The other way to solve a quadratic equation is by completing the square. Let's demonstrate this method with an example. Suppose we want to solve this equation, x squared plus 4x plus 1 equals 0. We want to find the square of the form x minus r squared, such that this gives the first two terms of our equation. So what we do, we expand x minus r squared as x squared minus 2r times x plus r squared. Now we see that x minus r squared minus r squared is equal to x squared minus 2r times x. So what we want minus 2r to be equal to 4. That is, r is equal to minus 2. So now we can replace x squared plus 4x by x plus 2 squared minus 4. We still have the plus 1, and this is equal to 0. Now minus 4 plus 1 is equal to minus 3. We take that to the other side. So we have x plus 2 squared is equal to 3. And now we solve this. X plus 2 is equal to plus the square root of 3, or x plus 2 is equal to minus the square root of 3. So our solutions are x is equal to minus 2 plus the square root of 3, or x is equal to minus 2 minus the square root of 3. So we found our two solutions. In general, the method of completing the square is as follows. Write ax squared plus bx plus c in the form a times x minus r squared plus s for certain constants r and s. From this form you can find the solution to the quadratic equation as in the example. Let's summarize. We can simplify an equation between two polynomials to an equation of the form px equals 0. If p is of degree 2, then there are three ways to solve the equation px equals 0. Factorize, and if you don't see how to do this, then use the quadratic formula or complete the square. Now, what can we do with equations of degree 3 or higher? We will consider these equations in the next video.